Yes, how important are science and invention for the wealth of nations? For explaining why are some countries rich and other poor. This presentation is about an empirical answer to that question. Recent work done with Carolina Rojas Garcia, we estimate what has been the effect of the number of researchers active at country level on future economic development across the world. Let us begin straight into our main results. We found that the history of research activity, the number of researchers per capita, predicts economic development over the long run better than any other established predictor, better than past development, education, or political institutions. The predictive capacity of research has been subject to swings. After all, we are dealing with research, which is a risky investment. And the effect has been consistently increasing through time over the long run, so that the elasticity of income per capita with respect to research per capita has been growing at about 0.1% per year. That means that we had almost no effect prior to 1820, but since then has been growing, so that today doubling the number of researchers per capita is associated with an expected 30% reduction of the long-term income gap relative to frontier economies. Other insights of our research include that in Europe, the Reformation and Counter-Reformation were crucial episodes for shaping the geographical distribution of researchers across the continent. And also for many non-European nations, we find that the greatest changes in the research intensities happened prior to the modern growth regime, meaning that the number of researchers per capita in a country is not primarily a function of income and population growth. Research is rather exogenous to income and population. Two further insights which are very interesting is first, the aggregate number of researchers worldwide has been growing at a steady pace, resembling a calendar fact since about 1730. That is a striking fact. And then we also have that history becomes more important every year. You will understand what I mean by that at the end of the presentation. So here's how I'm going to structure the presentation. First, I'm going to talk about the data. Is it reliable? Can you believe all these impressive results I was talking about? Then I'm going to refer to the issue of causality, and then I'm going to present you our estimated effect of research on the economy. This is data we are going to use. It is basically Wikipedia. Is it a joke? No, not at all, as you will see. We obtained the data from Wikipedia, which corresponds to a repository of structured metadata contained in Wikipedia, such as the information you can find in the info boxes to the right of the Wikipedia pages, for instance, birth dates and birthplaces of important people. And additional information such as the type of entity that the web page is about, say whether it deals with a person or whether the person is tagged as a politician, artist, scientist, or whatever. We downloaded the profiles of people tagged as pertaining any field of theoretical or applied science, astronomy, biology, medicine, and so on. We included also mathematicians, ancient philosophers, inventors, discoverers, pioneers such as the Wright brothers. In other words, people that have substantially contributed to the stock of knowledge of mankind. We will call them researchers. The resulting dataset is huge, with more than 40,000 researchers. But the question is it reliable, or is it biased towards specific countries or regions? If high-income countries are overrepresented in the data, what could easily be the case given that high-income countries have more access to the internet, access to better education, more English-speaking population, and so on, if that's the case, that could lead to an overestimation of any correlation we find between research and economic development. So the question is the Wikipedia biased towards high-income countries? If yes, we should find an overrepresentation in the data when comparing it to unbiased metrics, which could be, for instance, the official number of researchers per capita. Or, what is even better, an output indicator such as the number of scientific articles produced by a country. Because, after all, what you find in Wikipedia is are famous researchers, not just the input of research, but the output of research. But when performing such comparisons econometrically, we find no sign of overrepresentation, neither as a function of income, which is the really important result, nor as a function of internet users or linguistic dummies. The only distortion we find corresponds to two existing biases. First, an overrepresentation of countries which have higher shares of English-speaking population, say India, for instance, is overrepresented vis-a-vis Spain. But this is a very mild bias, not affecting our main results. The other is a relatively large bias against East Asia, and we are going to control for that in our regressions. So, as an example of the non-existence of an income bias, here you have the number of scientific articles per capita in 1919, according to the National Science Foundations, against the number of researchers per capita in 1919, according to the Wikipedia. If high-income countries will be indeed overrepresented, then you should find that the Wikipedia researchers per capita have an elasticity higher than unity with respect to the scientific articles per capita. But that is not the case, at least not when we look at the last 4 decades or so for which we have data. But the question is, what happens to really historical data, to all data? Certainly there has been there has been loss of information across the centuries. Yes, think of the destruction of the Library of Alexandria or the destruction of Baghdad in the 13th century and so on. So we are sure that if we're talking about the Aztecs, the Phoenicians, the Minoans and so on, we have no clue about which important researchers the society may have produced. So looking at data which is very old is probably not a good idea. Say data that is older than 1500 or so. But it is going to be much less likely that you have big losses of information after 1500. So we are going to constrain our data or analysis of the data to dates after starting with the 15th century, actually. Another question is whether the Wikipedia coincides or not with other sources of the history of science. Unfortunately, we do not have good sources for comparing at a worldwide level. Most sources of the history of science tend to be for specific regions and so on. But at least we can compare within the West. We may take a look at the big four of research, historically speaking, which are Germany, France, Great Britain and Italy. The red line here corresponds to the Wikipedia, the data we're going to use, and the dotted black line corresponds to Murray 2003. Murray 2003 is a source which draws on several compendia. It has been accused of exaggerated Eurocentrism, but it should be no problem, I think, for comparing across these countries. And you can see that the fit in general looks reasonable. No? You only have here a major discrepancy, but that's because the data of Murray for 18th century Italy is very bad. If you compare to other sources, you will confirm that the Wikipedia is indeed, it looks fine. It's very good. So now we can move to the issue of causality. Is the number of researchers in a country a function of income and population? Our answer to the question is going to be a clear no. Here we can see log scale, the aggregated number of researchers worldwide since 1000. The first time I saw this graph, I was amazed by this part, starting at about 1730 or so, and which corresponds to a strikingly constant growth of worldwide researchers. My initial belief was that this constancy, which seems almost like a new color fact, right, was driven by the modern growth regime, in the sense that income and population were driven, that were behind that shape. But this graph already shows you that that idea is not very convincing, because you have that part as well. Perhaps starting with the printing press in 1440, lasting more than 100 years. This period was certainly not characterized by modern income and population growth rates, so you cannot explain that by modern growth dynamics. The fact that research activity has been rather independent of income is very clearly shown in this graph, where you have in the x-axis the number of researchers per capita in logs, and here you have the log GDP per capita. So if we focus on Sweden, for instance, we see how for a constant GDP per capita, researchers took the number of researchers per capita took many levels, it started to rise, and then for a given number, steady number of researchers per capita, income exploded. That means that the research density of Sweden was determined before the modern growth regime, and that inverted L shape is to be found again here in Japan, for instance. You have it in Italy, you have it in Germany. In Germany, actually, the number of researchers per capita falls during the modern growth regime. You can find that in China, in India, in Argentina, and Brazil. It's kind of ubiquitous. Most countries tend to have a variant of this inverted L shape. What we can conclude out of that is that research is exogenous to per capita income and populations, in the sense that this cannot be primary determinants of it. And one implications is that you can treat past levels of research as exogenous to income in regressions without a need of instruments. So now let's look at the estimated effect of research on economic development. We will first look only at Europe. That's a way of overcoming any sort of Eurocentric bias of the data that might be in place. And then we're going to look whether we find the same results or not for the whole sample. So this is Europe. You can see how dramatic the changes were in the research landscape between 1515 and 1820. These are the researchers per capita. Most of these changes happened prior to 1700. If you take a look at the time series, you will see that they seem to be pretty related with the events of the Reformation and Counter-Reformation. And the Southern Europe falls behind the rest of the continent. That's one of the big developments. But you also have Belgium and the Netherlands here. Neither in 1500 nor in 1820 was the number of researchers per capita very closely related to income per capita. However, if you take the number of researchers per capita of 1820 and you plot it against income per capita in 1913, you find this strong fit, suggesting that the first 100 years of modern economic growth were very closely associated to the geographical distribution of researchers across the continent. So here we have a look at cross-sectional regressions capturing this idea. Per capita GDP of 1913 is a dependent variable, and as regressors we have the historical researcher densities for 1500, for 1600, 1700, 1820, and the corresponding historical GDP per capita, which is important to include because of what some people call the history course. Countries with more income in the far past surprisingly coincide with those that have higher income today. And a dummy indicating whether the data comes from Madison or from later revisions of the historical accounts. So the effect, you see it remains strong and about 0.3 starting in 1600, although the R-square is very low here, starts to become pretty high after 1700 or so. And that stands in contrast with what you see here in the first column, where research per capita do not predict income in the early industrial period, after the first 100 years of industrialization. Why? Why do we find that it matters after 1700 or so, but not before? Well, because there is no persistence of researchers from 1500 to 1700 across countries. But on the contrary, you have a very strong persistence from 1700 onwards. That's Europe. So what happens when we take a look at the worldwide sample? This persistence I was talking about is actually it's much older for the worldwide sample. It goes back to the 15th century. We therefore expect that all densities of researchers, very old densities, are going to be related with current income levels. And this is what you see here. You have the log income per capita in 2005, say income today, is related to the number of researchers per capita born in the 20th century. That's no surprise, but it is also correlated to those born in the 19th century, and to those born in the 18th century, to those born in the 17th century, to those born in the 16th century, and even to those born in the 15th century, meaning that income today is correlated with the density of researchers of the 15th century. Here you can see the same idea with regressions, which are analogous to those shown before. What now? The dependent variable is income in 2005. What stands out here is not only that the coefficients are very significant after control for GDP and so on, but that they are homogeneous. They tend to be around 0.3 again. Why? We believe that this is reflecting the, so to say, the legacy of research cultures, and that is very old. We can control for schooling, since in our days it is both related to research, and this is what the established literature tells us, it is also related to economic convergence. Indeed, the primary enrollment of 1900 is closely related to per capita income today, so is as well the schooling index of 1960. But if you control for the number of researchers born in the 19th century per capita, you will find that the significance of those coverage vanishes. So suddenly schooling doesn't matter anymore. Something similar happens to the executive constraint. If you included the researcher per capita in the regression, the executive constraints do not longer act as robust predictors of economic development. So we can conclude that, given our estimates, that a country that has doubled the researcher density between the 15th and the 19th century, no matter exactly when, that country has today per capita GDP which is between 20% and 40% larger. Yeah? By the way, doubling the number of researchers is not an utopian endeavor. The US almost doubled the number of researchers from 1930 to 1980, whereas the Europeans did not have that development, and perhaps the US will have income levels which are more close to those of European countries if that event would not have happened. And well, Japan increased the number of researchers per capita by an impressive factor of 10 shortly after the Meiji Reformation. Well, but returning to our estimates, the homogeneity of these estimates from the 15th to 19th century suggests somehow that it must has been after the 19th century that research really started to matter. So when exactly did that happen? We have here rolling cross-sectional OLS regressions with the income gap as dependent variable, and as one of the explanatory variables, we have the researcher gap with respect to the frontier economies. We are going to be interested in that coefficient, which is going to be rolling. We have different years and different lags. So if we take a look at the 20 years lag, we see that researchers per capita start to you see that the effect is volatile, but it starts to become positive and significant at about 1850, and with these big swings, you see that the trend is increasing over time. The same you can find with lags of 50 years. Research is getting more and more important, and also if you take 100 years, you see the same idea that research is more important for closing the income gaps. But you may ask, could these results be driven rather by biases of the data, say Eurocentric over-representations of in the data? Well, in order to avoid that problem, we also run panel regressions with counterfixed effects, which should be immune to that problem. So here we have Ariano bond estimates with the lagged research density here and the interaction with time. And you can see that the coefficient of the interaction is positive, meaning that over time research is turning more important for closing the income gaps. And here we have also the time series autocorrelation of the dependent variable. And if you compare the magnitude of the estimates, here we have the multiplier, which begins at about 0, but then it turns to a value which is about 0.2, sorry, which is not far away from here. This other one is 0.25. That's also not far away from here, as you can see. And if you take 100 years of lags, you get a coefficient of 0.3 for 2010. That's also not very different from what we got in our cross-sectional regression. So we can conclude that the result is robust, and that the role of researchers closing the income gap with respect to frontier economies has been increasing over time. One last insight before ending. GDP has taken the shape of all research. That's a striking fact. What we did is estimating again cross-sectional rolling regressions, holding regressions constant, only changing the dependent variable, GDP. This is what we find. For instance, 15th century researchers are not very related with income through history, but in the recent years they do. And if you take 16th century researchers per capita, the importance is growing over time. The closer we get to the present, the more important are 16th century researchers explaining the wealth of nations. The same holds for 17th century researchers or 18th century researchers. So how do you explain that? The more time passes between income and early historical researcher density, the stronger the cross-country relationship among them. The more time passes, the more important is history. Why? How can you explain that? Well, we already saw that the importance of research for closing the income gap has been increasing over time. And we also saw that in the cross-section we have a very strong persistence of researcher densities through centuries. If you combine both effects, you will end up with something like that, that history is becoming more important every year. That's all. Thank you very much for watching. I hope you enjoyed the presentation, and if you have comments, please write me an email.